Hi everyone, welcome to our first study session of the year. We'll be jumping right into the hard topics today of networking. I know that this one has given me and a couple other people that I've been working with a lot of trouble in the past, so we might have to go over it twice. So if there's any questions or if anything's not super clear, just let me know so I know where to focus my studies on, and I can translate it or relay it to you guys better. So, networking. As with any other systems in IT, we have to have it in place for devices to be able to communicate with each other. In Kubernetes specifically, this will include our pods, nodes, and clusters. They all need to be able to reach each other's networks. So we have to set that up. Today we're going to cover specifically the CNIs, which is going to be our container network interfaces, and they're what are used to set up your networking. And then also we're gonna cover DNS solutions that well, they do just that. They run the name services in Kubernetes so that devices don't have to communicate just by IP addresses. Uh, and we're also gonna cover a little bit of troubleshooting of those systems. So let's go ahead and jump in it. So
Uh, our first question here is going to be spec the kubelet service and identify the container runtime endpoint value that is set to Kubernetes. So let's go ahead and check the kubelet. So QK, the kubelet service. So the kubelet runs as a service on the Linux machine. So to check the service, can do a PS. Let's do a PS-EF, and we can grep for the kubelet. All right, so here's a kubelet, and it's asking us to identify the container run point that is set for Kubernetes. Container runtime endpoint value. Let's also grep for endpoint. So we get here. Here we go. So container runtime endpoint got containered. So here's our answer right here. And what is the path configured with all the binaries of CNI supported plugins? Path configured. So here it's asking us to check the CNI. Path configured with all binaries. Let's walk through this. Been a while since I've worked on this, but let's see if that's also a configuration that's set for the kubelet. It's not. Path configured all binaries. CNI supported plugins.
So there's a excuse me. There's a few ways you can do this. I'm not too good with. I don't want to say I don't want to like say that, but you have like the find command. You can always try that. Like you can find and then look for the in the whole file system CNI, because obviously there's a folder in there that looks like it's named CNI somewhere that we're trying to look for. So you can do like the find option. But in this case, um I would recommend probably starting in the Etsy folder, and just seeing where, because a lot of the Kubernetes things are usually in the Etsy or the var file usually.
Mhm.
So I would probably say look there first. But if anyone is struggling, always try to use a find command if you know like the name of the folder that you're looking for, and it just does the a recursive search.
Okay. Let me check one last thing. Kubelet does not run as a pod actually, right? So yeah, let's go ahead and we can do the find command. And we can find the CNI. Yeah, that should be simple. So we'll do find all, and then we can grab from there for CNI. Let's see what we.
Oh, the backslash
Yeah,
is gonna like
yeah. I've been working in Windows too much. All
Yep.
right, so here we see I saw an SCCNI over there, so we can jump in there. Let me go ahead and cancel this, and let's check there first. Slash Etsy CNI, and see what's in here. Okay, so here's our Etsy CNI. Let's see, is that only one thing in here? Okay. Looks like the only thing in here is gonna be the flannel. So what is the path configured with all binaries of CNI supported plugin? So it looks like it's gonna be SCCNI net D, but I do also, it's not. CNI, the only directory that we had.
Look through the find command and the results in there, and it should give you like more paths to search.
Yeah, I mean, I'm pretty sure it's gonna be in, then the other option is gonna be, let's go ahead and look through there. See what we got. I do want to check that opt directory. Yep, there it is. So let's check the opt directory. And that's our all of the binaries right there. So opts in. But I want to see the hint here. Well, it just tells you the answer. I would like to find a way to actually find this configured in Kubernetes.
Can we look? I don't know if this is because I didn't know the answer to this question. So that's why I was saying to use those options. But look at, because do you guys know where the kubelet? Because there's a kubelet configuration file. Maybe it's in there.
Yeah. So let's go ahead and cat that, which is going to be under Etsy system D. Systems, leave, yep, system. And kubelet should be here. Yep, kubelet service D. Kubelet, yeah. Okay, so let's cat that.
Is there anything in there that shows it?
Okay. No, nothing here, but this doesn't look like all of the
Look,
configs.
yeah, this is the service itself. If you look in the var lib section,
Yep.
var lib kubelet, that probably give you a little bit more.
Here's a
Config, yeah.
config.
Mm-hmm. Maybe it's in there. I don't know. C group driver, no.
Let's see it. Just to make sure. Search it. No, we don't have anything in here.
Okay. All right. Cool. It's always good to search around. So good stuff.
All
Good
right.
stuff.
For the time being, we'll move on and we can look into that later. Identify which of the below plugins is not available in the list of available CNI plugins. And that will just go back to that directory that we were just in. Was opt. Okay, so I'm gonna go ahead and ls/opt/CNI binaries and list everything here. And we're just gonna just cross check them, see which one is not listed. As you can see, DHCP is in here. Bridge is also in here. And Cisco is not. VLAN is. Here's VLAN right here. So the only one that's missing from here is gonna be our Cisco. So that is gonna be the plugin that is not available as a CNI in Kubernetes. Uh, what is CNI? What is the CNI plugin configured to be used in on this Kubernetes cluster? So there is a folder for this. Mm-mm. How do we find this? So let's check. Let's see. Oh, let's check all of the pods that we have available. Dash A. So as you can see here, we have flannel, and that is gonna be our CNI that is being used. There is probably another way we could check this. Let's check what the configurations for the API server is.
Give you a hint. We just were in that folder.
The opt CNI folder,
The one before that.
or the NC folder. Oh, right.
Mhm.
It did say in there if the flannel was being used.
Yep. That's what I thought the question was asking. So that's why I was like, oh, I was wrong.
I think I remember going through this, and I think I did see this configured on the API server. I just want to double check. If it's not, then it's not. And can you describe
For sure, for sure.
pod dash n? And we're gonna do system cube system. System. And the pod is gonna be our cube API. And then let's go ahead and just grab. One, one. Looks like it is not. All right, so it is not. So you have to go to the Etsy and the what was it? Etsy CNI folder, Etsy CNI netd, and that's where we see the flannel is being configured. So let's go ahead and choose that. What binary executable file will be run by the kubelet after container and its associated namespace are created? Binary executable. So it's gonna be flannel. Okay. I was worried that it was a trick question. Okay. So that's gonna be all for that. Um, let's go ahead and jump on to the next one. Deploy network solutions. I we missed one. We did miss the exploring environment. So let's just do that one real quick, and then we'll come back to deploy network solutions. All right. So this is stuff that we've done in the past. How many nodes are part of this cluster? Does anybody want to try their hand at this one? You guys remember the command that lets you pull the resources that are part of the Kubernetes?
Anybody?
We did take 3 weeks off. 2 or 3 weeks. 2 weeks off, so I understand. Pat, do you remember?
Hey, I'm sure it starts with a get.
There you go. So let's go ahead and get, and we're just gonna get nodes.
Gotcha.
And we got two nodes here, control plane and node one. So let's go ahead and put two. Uh, what is the internal IP address of the control plane node in this cluster? For that, we're just gonna get more information, which we can do by adding an option for wide, and that'll just give us extra things here to extra description here to read. So let's do it all wide. And as you can see, like now we're able to see internal, external IP, the image, and the Kubernetes version, and the runtime. And in this case, we're looking for the internal IP address. So, and for the control plane. So here it is right here, 161.3. And what is the networking interface configured for this cluster connectivity on the control plane node? So for that, we have to check the interfaces that are configured for, we're currently on the control plane, as you can see. So we have to check the interfaces are being used here. So for that, we'll do an IP address, and which can be shortened to IPA, and that will list all the interfaces. And we're just gonna look for the one that shares that internal IP address. So we can also just I haven't actually tried it, but assuming we can grep it. We don't need the dash I, but I already have it there. And it could be 192.3.161.3. But it doesn't tell you. It does say here it's Ethernet 0, but I would say, let's see. Here it is right here. And it is Ethernet 0. I'm curious, PJ, if you know, is this always gonna match your interface name?
The interface name, it should. Another way that I would recommend you do is just do you could do a grep minus capital C, and then put the number of lines that you want to see before and after that matching, um, that matching key phrase or word or number. But it should. But yeah, I would probably just recommend you just doing that, so you can do like grep minus capital C like 4 or something like that, and it will give you the line that is on.
Yep. I'm wondering also if it's always going to be on line 3, so then I can just do a B-3.
Oh, I don't know. That's a good question. It looks like it's pretty consistent though,
Yeah.
because it gives the name like the broadcast, and it gives the link, and then it gives the actual address on the third line.
All right. But yeah, thank you, Pat, PJ. The answer is going to be Ethernet 0 is going to be the interface that is being used by the control plane. So we can go ahead and hit that. So next up, the MAC address. So the MAC address is gonna be is gonna be the same configuration here or the same interface here. So we just gotta look for the MAC address, which is gonna be this guy right here, and just match it. The one ending with 03. So there's our answer. And what is the IP address assigned to node 01? So in the case of node 01, we won't be able to see it on this. Well, the IP address we can see it. We can see it right here. So go ahead and select that. The interface itself, though, we would have to jump onto the machine and see to look at the interface. As far as I know, you could correct me if I'm wrong, PJ. So to do so, we're gonna go ahead and just SSH over to node 01. And we're gonna do the same exact thing. Let's go ahead and do an IPA. And we're gonna grab, and we'll do a -B, 3 lines. We'll go ahead and 192.16, 192.3, 161.6. All right, so here's our interface. Again, it's a interface 0, and here's the IP address, and here's our MAC address that it is asking us for. So we were looking for A106. It's going to be this first one here. Does anybody have any questions on those?
I wonder why you had to log into Node 01 to see this information. If you're the root user, how come you aren't able? I mean,
Mhm.
maybe I'm missing something.
Because in this case, control plane and node 01, they're I don't know how this is set up. They're either two different VMs or they're two different containers. So
Oh,
we
okay.
cannot see the interfaces for the other container or VM. Um, I'm pretty sure it's a container. But yeah, we have to jump onto that container, or we have to go into its shell. We have to log into it and do those commands from it to see its interfaces.
Okay, so maybe I'm not thinking of this correctly, but is it like possibly in a different cluster, or they're in the same cluster but different nodes and too far apart to be able to look at each
So
other?
yeah, so this is not necessarily it's not a Kubernetes. Of course, there are different nodes, but it's the infrastructure that the nodes are running on that we're looking at. That's where
Mm.
we need to
Oh,
look
okay,
at the
okay.
interfaces. So you taking your Linux courses. So if I remember correctly, like you have labs there. Are you using the labs that come with the RHCSA?
I have, yes,
Yeah, so in those labs, you're logging into each machine. Have you gotten to the networking side of things?
yes.
But yeah,
So,
it's pretty much it's just think about them as two completely different VMs. If
okay,
you've done that side of things in the RHCSA class.
thank you.
Okay. So we're gonna jump back over to the other machine. So we're gonna exit out. And next question we have is we use container as a container runtime. What is the interface bridge created by container on the control plane node? Thank you for asking the question, by the way, Leslie. It's a great question.
No problem.
Say again?
Oh, I said no problem.
Uh, okay. So it is asking us about the interface bridge that's created by Container. So for that, we're gonna do, and the way I usually find it is I just look for the type of interface that is a bridge. So could do an IP address show type, and that way we can it's pretty much like grepping. We're searching that through all the interfaces, and it's only gonna pull the interfaces that are bridge, that have the type bridge. So as you can see, there's only one that pops up with that, and that is gonna be our CNI 0. So that's gonna be our answer. And just to give a little bit of insight to what a bridge network is in Docker. I believe this is a Docker thing. It's not just a Kubernetes thing. Um, so a bridge network is gonna be. Okay, let's go back a little bit. So there's three type of networks that you can have. Uh, three type of network that you have set up for your Docker containers. You can either have node network, which your Docker your containers will not have any outlook into the outside of the container itself. Um, the next way you can have it set up is host networking, where you link that container to a port that is on the host. And in that case, only that one container can then see outside of the host, as far as like you connecting to them and it getting anything coming into it. So your ingress and egress is all going to be going through that one port. And the last way that you can have it set up is you can have set up a bridge network, which that bridge network is going to be also connected to a port on the host, but then multiple containers can connect to that bridge network. And then that allows multiple containers to then communicate to the outside world. So that's what a bridge network is. Uh, and in this case, they are using the CNIO as the interface for that network. So let's go ahead and select that. Any questions on that? No, it's a kind of shabby explanation.
No, that's fine.
Okay. All right. They want us to check if the state of the connection. We can see that right here. State is up. So let's go ahead and select up. And if you were to ping Google from the control plane node, which route does it take? So for that, we're gonna do an IP route. And these are all just Linux commands. We're not actually going through Kubernetes for this. So let's go ahead and do an IP route. That should give us, yeah. So that will give us our default route. The default route is that's gonna be your route that anything that's not configured. Like we have these routes configured for anything that you're gonna be sending packets to 10.244 /24. They'll take this route here. Or yeah, sorry. Source. Yeah, so they'll take this route to get to this network. Anything outside of that is not configured, that it cannot find, it will send it to this interface, Ethernet 1, 172.25.0.1. And that's going to be your connection to the outside world. Okay, so as it says here, that page is a default gateway, 25.0.1. There you go. And what is the port? The kube schedule is listening on the control plane node. So for this one, we're gonna do can do, there's multiple ways that we can find this. Let's do a net stat. Okay. Net stat. Dash help. We need the numeric. And that's just so we don't show names. It's actually gonna show IP addresses. And sorry, port numbers. Numeric, what else do we need? Listening. We try to find what port the queue schedule is listening on. And so for that, we also need to check the programs. So yeah, let's do that. NPL and all sockets. So what's that? Dash NPLA. And we're looking for cube scheduler. Sorry, we're gonna do a grab. I cube. What should do cube? No, okay, so everything else pops up. Let's do cube scheduler. How's that spelled? Is there a space? Let me actually do just scheduler. Okay. If here's our cube scheduler. Yeah, so it is listening on 10.259. Okay. There's our answer. This is also configured in the, if we check describe -n system pod scheduler. And let's see its connections. Yes, it is not. I could have sworn it was.
Are you looking for the IP address?
No, I was trying to see if the port was gonna be configured in the, let's check the its manifest file. I'm just curious here. It's not, we already have the answer, but yeah, curiosity kills the cat. It's cat slash Etsy Kubernetes manifest, and it's gonna be scheduler. Oh, here it is. Well, it's where the probes are configured to check the port 10.259 to see if it's working properly. I guess it's not actually configured here either. This is just the default. Then I'm assuming there's probably a way you could change it, but this is gonna be your default port that it uses. All right. So notice STD is listening on 2 ports. Which of these have more client connections established? So for that one, let's go ahead and do the same command, but this time we're gonna check for etcd. Okay. And we can see here that 2379, pretty much all of them are listening on 2379. But we do want to know in the case that they try to trick you and they throw a whole bunch of them out there. which in the real world, you're always going to have a lot more 2379s than 2380 just because 2380 is used for etcd communication between two control plane nodes. So you're not gonna see that many of them. So let's go ahead. We can do another grep or no. Yeah, we'll do another grep. Gosh, well, we don't need that. And we're gonna grep for 2379. And then we're just gonna word count -L. And what this does is just counts how many lines are present that have 2379 in them. And we got 63. And then do same thing for 2380. And we only have one. So 2379 is gonna be the one that has more client connections established. Correct? Yeah, for the CD which the control plane components connect to is only a CD peer-to-peer. The control planes talk to each other. PJ, is there anything that you want to add as far as 2380? I know it's like that's where that I'm assuming that's where like the synchronization happens over 2380 between two different control planes.
Yeah, I don't really know anything else beyond that. I would have thought it was like the actual etcd because you have like the primary etcd. Does the communication from those go through that as well?
That's what I meant by
Oh,
synchronization. Yeah.
okay, yeah. But yeah, anything more than that, yeah, I just remember 2379 for the etcd. But yeah, 2380. I didn't memorize the 2380 and its purpose. So thanks for reminding me. But you guys, that would just be a good to know. But I don't think it'll be anything like you would need to know as far as for like an exam purposes. But real life, yeah, it could be useful.
Okay. To know. All right. So let's go ahead.
I'm glad you said that about the memorization because it wasn't intuitive to me that 2379 was and its purpose, but maybe it was something that was in the lesson for this week. That
Mhm.
okay, so
Yeah.
that's good to know.
Okay, let's go ahead and jump onto where were we at? We did the CNI. So deploy networking solutions is going to be our next guy. So let's go ahead and jump right into that lab. Where'd it go? Okay. Networking solutions. There we go. It's a short one. Any questions so far? All right. So for this one, we're we're installing WeaveNet pod network solution to the cluster. Let's first inspect the setup. Build an application called app in the default namespace. What is the state of the pod? So they deployed an application called app for us, and yeah, we're just gonna be checking what's going on with it. So, does anybody want to take a shot at this one? How do we find the state of this pod? Let's go ahead and do key describe, and we'll do the pod. Let's see if it's here. There it is. And we can also just do a, let's just make it easier on us. Rep -I state. Waiting. It's not running. It's waiting. Why is it waiting? Let's
Yeah, why is
see
it
if we
waiting?
can, yeah, let's find out. Here where we see it. State waiting.
They're creating the content of container.
Container creating. Let's check our events here. Actually, the next question is to inspect and see why it's not running. So, the container is creating. So, a lot of the times that I think that a container is not being created, I always think about the scheduler. But in this case, you can see that it was scheduled by the kube scheduler. So, next up, let's see, failed to create pod sandbox by the kubelet. And why is that? Unknown description, do you see here? Failed to set up network for the sandbox. Plugin type, weavenet, name weave, failed. So, and then unable to allocate IP address. So the issue is we don't have a network set up for this, and it's failing because of that. So, there's going to be no network was configured. So, deploy weavenet network solution to the cluster. We already have provided the weave manifest file under root weave directory. We just need to deploy it and wait for the app to run. So let's take a look at that. So that they have the manifest file here. And we're just gonna go ahead and cat it and see what exactly is setting up here. There, there it is. Oh, it's okay. And it's a weave daemon Kates. And yeah, it makes sense that they would want to set this up as a daemon set because of the fact that you want to have networking on every single node. And that's what daemon set does, that even if after we set this up, if we were to add a new node, this pod would get created on that node as well. And therefore we'll get our networking set up on that. And we don't have to keep deploying it every time we add a node. I just wanted to read command list. Yeah, the service. There's a lot of configurations here. What's that list of that? Yeah, let's go ahead and deploy it. Here's a container with Weave. All right. All right. Let's go ahead and deploy it. And for that, we're gonna just do a create and use that file that they gave us. Yes, Weave. Oh, okay. So let's then do okay get pods dash a, see if it was still creating there. Well, the Weave, you can see it is set up and running, and is we have two because we have two nodes available, and it's still container creating. So let's do a. I just add a W here. Yep. So that lets us. Oh, it's already. That was too late. It's already running. Let's see. So let's make sure. All right. So that's it. Okay. So just to summarize that one, pending me something is up with the schedule. Also, if you dang, I wish I didn't close that because I could have sworn. Um, so the pod was pending, but the container was waiting. PJ. So I'm curious. When it is waiting for a schedule, is the container also pending?
And can you ask that again, bro? I'm brushing my teeth. Sorry.
Yeah. So in that case, when I looked at it, the pod was pending, but what was waiting was the container, the status of the container. Or yeah. So in the case that because you mentioned in the chat that pod equals pending means that something is up with the scheduler. Uh, would the container also say pending?
That's a good question. I don't know, and that
Yeah.
makes me think that statement is not the best statement to say in that case. Then, I would say start at the the scheduler, and then go
Mm.
from there to see if there's anything else that's wrong, like the networking.
And that's exactly what I've been doing. And
Mhm.
it'll say right there that if in those events, it'll say that your scheduler did actually create it. Here, I'm gonna just look at it real quick.
Mhm.
Describe pod. Hopefully it's up. No, they're still creating it. So let's give them a second here. But yeah, in summary for this section, they deployed an app called app that was not running, and we went through all of the event logs to pinpoint that the issue was with its networking, and
Mhm.
that's because Weave was not set up, and then we deployed Weave, and we right after the networking was added, we can see the pod. Kubernetes just starts that pod, which I'm assuming is a deployment. Here it is, pod app. If I can go, can you describe deployment? Oh, it's not a deployment. Okay, so let's go back to pod. And as I was saying, like you see here, it is the status is pending. The
Mhm.
state of the container itself is waiting. But it
Right.
does say here that it was successfully assigned default app to the control plane.
Gotcha. Yeah. So if it's something related to the to the scheduler, it would say like 0 out of 2 nodes like met the requirement or something like that, and like no node is schedulable or something. So it will say that verbatim. So you'll kind of know. But this one is a little bit different where yeah, I haven't really seen the container and it's saying like in a creating state and it's just waiting. So that's interesting.
There's something else that prompted me because it said there was assigned to the control plane, which made me think that there is only one node available, which is the case. There is only one node.
Right.
So then that that brings up the question: our create for our daemon set. Why does it create two apps? Was there two apps? Oh, it did not give it to us yet. Jumping ahead. There it is. So in this case, we create this and then we give pods dash A. Oh, so it's two containers there. Two containers. Yeah, it is two containers. Sorry, so I said earlier that it was two pods. There's only one pod for Weave that has two containers in it. Sorry about that. In the case where you would have two pods, you would see like the core DNS here. You see that there's actually two entries for it. And that's for redundancy. Just you don't want to have the DNS fail if one of those goes down. But yeah. All right. We've deployed Weave. I'm sure the app is working now. All right, so let's go ahead and go on to the next lab. Did anybody have any question on the previous lab as far as the Weave network?
Good stuff, man.
Well, if you did, the next one up is a practice test on the networking Weave. So let's go ahead and jump in there. Thank you, PJ, by the way.
Of course, bro. Of course. Thank you.
All right. So how many nodes are part of this cluster? We did this one earlier. Does anybody want to tell us how many nodes or how we find how many nodes are here?
Get describe.
We can't describe all the nodes, but I think it's can we? Can you describe node?
Get is
I think that would be a little difficult to you're making it harder on yourself.
right. You want to do a get, right?
Correct. So let's go ahead and okay, get node. We can do node or nodes, the same thing. So yeah, as you can see, we got two nodes today, include master and worker nodes. All right. And what is the networking solution used by this cluster? So we can go ahead and do network solution. So that's going to be your CNI. So we can also, yes, we can do a K get pods A, and we'll see the pod with the name that's using that specific networking solution. But we could also go ahead and do cat, and it was at CNI and netd. And we got Weave today. So it's gonna be our CNI. And just to double check that, K get pods dash A. As we can see down here, we got our two pods for Weave, which are looks like they're set up as a daemon set. This one did crash at one point. It was restarted. So Weave is gonna be our CNI here. And how many Weave agents peers are deployed in this cluster? And yeah, as you can see here, it's gonna be set up famous set, so we got two of them. And I may be going a little bit fast, just feel free to slow me down. Um, on which nodes are the Weave peers present? So I'm sure they might ask this later, but we can do a K get DS dash A because they're not in the default namespace. And here's our weave. So them being a daemon set, there should be one present on every node. So let's one in every node. I believe we can also do K get pods dash A dash O wide. And that will tell us what nodes they are running on. So as you can see, here's our weaves. And there's one on node one and one on control plane. So next up, identify the name of the bridge network interface created by Weave on each node. So right now we're on the control plane and we can do an IP. We're looking for the bridge network. So we're going IP dash A or IPA for address show. I believe we could also just do an SH. They'll do the same thing. And there's something. Well, let's find out. I'm all for experimenting a little bit here. Be a show type and bridge. Yep. If you guys have ever worked with Cisco firewalls, you can shorten it as long as there's nothing else that matches the same shorthand. But yeah, IPA show, IP address, show type, bridge. And we got Weave Bridge, which Weave is the name of the interface that's using the Weave network. So let's go ahead and select that. And what is the pod IP address range configured by Weave? So for that, ooh, that's not gonna be the answer. I'm gonna find the configuration for Weave, which is probably, let's go back to that file. Cat flush, let's see. I'm curious what's in there. CNI, the what do we got here? Nothing about our IP addresses. Okay. We'll also describe pod dash and for namespace cube system. Let's go with this one. And we're looking for IP allocated. Wonder if, okay, here we go. Yep, IP allocated range is going to be 10.244.0.0. The pod IP address range configured by Weave. /16. This is not a /16. This is gonna be Location. Let's check the documentation here real quick. And we're gonna, if there's anything to weave. Pod IP. Here we go. Pod networking. Pod network cider. Oh, that might be. Let me check the IP API here real quick. It's gonna figure out one of these things. Okay. We're looking for, and just I want to add this because this is a community forums. This is not actually available during the test. So we won't be able to use this on the, like right now is pretty much we're cheating. I'm sure it's listed somewhere in the documentation, but it'd be a lot more helpful if to memorize this part. Can you describe pod, queue system, queue API server? Cluster IP. No, is that it? I don't think that's it. This is /12. Oh, not network side. We'll go back to weave. We'll have that listed there. Well, let's check. What is our CNI? Our interface set to? Doesn't quite match because I know this 10.x.x.x. That's gonna be a /8. It's listing it as /16. We can go ahead and click that, but before I click that, let me check the hints. So yeah, that is what I'm looking at. Okay. So this command that he's telling us to look at, PJ straight out. Hey, I wish he answered the last question, but take care, PJ. Thanks for coming out, man. You're a blessing. But yeah, it's telling us to run this command IP address show weave, which if we run this, it's gonna show us this the same thing, same output here. So let's go ahead and we're gonna use this. This the answer. Doesn't quite match, in my opinion, but hey,
Well, so why you think it doesn't match? Because of the 10xxxx?
yeah,
Right, because two of 244, they all if so all of that is falls within that range of 10xx, even if it was a slash eight. The slash eight is wider than 16.
of course.
Yeah,
Um,
so
I guess but the thing is that not everything that is 10xxx is gonna fall within the range of this 10/16, right? Because it would
right.
have to be 10.244.x.x.
Yeah,
So that's why it seems to me that it doesn't match because he's saying that look, the way I'm reading this is your IP for your pods is gonna be within this range right here, which does not include everything that is 10.x.x.x.
right. Yeah, it'll be everything after 10 244.
Yeah. So that's what's throwing me off. I was trying to get more info in here, but yeah, I mean, even the Kubernetes said that this is the gonna be our answer. So I don't know. They might have to change their documentation here. Does that make sense, Pat?
Yeah, yeah, 100%.
All right. What is the default gateway configured on the pod scheduled on node O1? Try scheduling a pod on node O1 and check IP route for IP route output. So okay, so first thing I noticed here, they wanted for node O1. So to check that, we'll have to go on the node O1 first of all. Kind of gives us the answer here though. Check IP route output. What is the default gateway configured on the pod schedule another one? So yeah, let's go ahead. I'm curious. Let's go ahead and SSH over to node 1. Node 1. And let's do an IP route. Now the default here is 172.25.0.1, which they don't even give us that answer. So that confirms my suspicion. So they want to actually get the route of the pods themselves, not the node one. So for that, we're gonna schedule a pod, and then we'll jump onto that pod and do the same thing. Again, this is similar to how we cannot see the interface of node O1 while we're on the control plane. In the same sense, we cannot see the interfaces for those pods until we jump onto those pods. So let's go ahead and create one. And we're gonna exit. And from here, we're gonna do a let's do a K run. And we'll do image, busy box. Name the pod. So we need a name for the pod. Let's name it busy. And if you guys remember with busy bugs, really with any pod, they need to have something running on them for them to stay running. If I just create this right now, it's going to immediately terminate and we're not going to be able to get onto it. So let's just add a command here onto it. And the command is going to be, I'm going to have it just wait. The wait command is 180s. And there's the container. Environment. Sleep. That's what I need. So I want to run the sleep command. So let's do sleep. I'm gonna space here, sleep command, and the time is gonna be, let's do 10,000 seconds. And the time doesn't really matter, it just needs to be up long enough for us to get onto it. So let's check, do a K, get pods. And there it is, and it is running. So now let's go ahead. Can do a K exec, which exec lets us run a command on the pod that we select, and we want the busy uh, pod. And command I want to do is yeah, we're just gonna do an IP route. Exec busy IP route. Okay, that'll give us. Oh, I'm curious. Could I have just and I'm just gonna this. The issue with this, if I was to just run the command here, I'm assuming that the output is not gonna give me the output. The output is gonna be inside of the machine itself. So let me just do IP route. Yeah, so if we do now do K get pods, as you can see, that one is a crash loop. Okay, describe. Should have not been a crash loop, should have been terminating. Everything. Back over starting field. Cleaner status running. Oh, it did terminate. As you can see here, it terminated. And the reason for that, it completed the command. I would love to know a way for it to have spit it, because it runs the command internally, but it doesn't output it to my terminal. That's why we weren't able to get those results. But yeah, as we saw earlier,
It does.
yeah,
Question. So there's no way to have the output showing on the terminal, just like you would run a Terraform, and you can have some of the you know some of the stuff as an output.
mm, not as
Is there
far
you
as
think you think there's a way to do that, or maybe it's just not an option?
well, let's do this.
Can't you do a watch command?
No, the watch command is just gonna watch, like it's gonna watch for what's happening to the resources on this machine. We need a way to look into what's going on the pod, on the container that we're creating. So what I can do is we could do a key run, and I just want to see all of the different arguments that we can use. So I'm gonna do a dash dash help here, and let's take a look. Show manage, see. Missing template, annotation, attach, dry run, environment. Well, here's an output. That's different because this is gonna output our configuration for the container we're creating. It's not gonna output what's going on in the inside of the container. Hmm. So, hmm. Yeah, I don't see a way to do so. We need to change the output. Hmm. Yeah, unfortunately, I don't see a way that we can do that, Pat.
Okay.
Yeah, we just do an exec. That way, and with a K exec is we're able to run commands, but it's gonna use our terminal as the output. So that's why we're able to see what's going on the inside. But yeah, in that case, let's just run the command again. Exec busy IP route. Our default route is gonna be 10.244.192.0. Here we go. Okay. That's it there. Oh, here's the fun stuff. Service networking. So I want to leave the service networking and the ingress for our next session because those kind of go together. And core DNS is, I think we can run through core DNS pretty quick here to end our sessions for today. So let's jump onto the core DNS. And in case anybody does not know, DNS is going to be our naming servers and the main naming servers. And what they do is match the name of your servers to the IP addresses. So you're able to search up a server by its name and not have to put in the whole IP address. This is important when you have services and things connecting by the names. And if that was to go down, you will lose connectivity across your network. And that is why usually the core DNS is deployed in a pair um, of two, sometimes even more, just so you have that redundancy. If you do have it go down, you have the other one to kind of just pick up the slack. So, any questions on that? All right, let's jump into identify DNS solution implemented in this cluster. So let's go ahead. Okay, again, pods dash A. What do we have here for our DNS? As you can see here, we have core DNS set up. So that's gonna be. I'm curious. Yep, that's what they wanted us to do. So that is gonna be our core DNS. Is gonna be our DNS solution. How many pods of the DNS server are deployed? And as we can see right there, we have two of them. And what is the name of the service created for accessing their core DNS? So yeah, let's go ahead and look at the services that we have deployed here. Service created for accessing core DNS. Yeah. Okay, get svc-a. And you can see here we have kube DNS. I want to describe that one real quick. what we can do is yeah, so this is how we can find out for sure, just to double check that. Want to look at the get endpoints. Okay, there we go, freezing me. Okay, we'll need that later. So let me go describe and name scheme cube DNS system pod or DNS. Okay. And we ended up describing all of the different both of the core DNS pods. And we are looking at the labels. And we have a key-app equals kubedns. And that's the one that's good night, Evelyn. Take care. So let's go ahead and do describe on all the services. SVC kubedns. Is that the only service that's available? I thought there was other. Oh, they were in different namespaces. That's why they're not showing up. And let's look at the labels here. And as you can see, they do match that Kate app versus equals cube dash DNS. And right here, Kate app equals cube DNS. That's how you can tell that they're linked together. So our answer is going to be cube DNS. And what is the IP of core DNS server that should be configured on the pod to resolve services? And so the way that a core DNS or any Kubernetes DNS solution works is it's gonna use the service as the name server. So to hit that core DNS, you need to hit the service, and then the service will direct it to one of the two core DNS pods. So to configure another pod to use those name servers, we just need to configure the IP address of the service, not the core DNS pods themselves. So as you can see here, this is the service that we're looking at, the kube DNS, and the IP address here is going to be the 10.96.0.10. So that is going to be what we need to configure on all the other pods for them to reach those core DNS servers. Any question on that? I know it's a lot. Okay. Anything, Pat?
No, I would say I'm good here. Thank you.
Okay. No problem. Where is the configuration file located for configuring the core DNS service? So configuration. We could go through and check all of these, or let's see, was there anything in here? Because we already described one of those. This is the service here. Right? No, this is one of the pods. So we're looking for the configuration file. Here it is. Yeah. So it's under the arguments. The configuration is set to etc core DNS core file. So right there. And how the core file passed to the core DNS pod. So I believe we'll have to do a little bit of digging on that end. So you can see here, there's an argument that the configuration is going to be stored here. So then we got to figure out, where does this come from? So if we scroll down a bit here, we are adding the Etsy core DNS. As you can see right here, we're adding the Etsy core DNS folder directory with a config volume. So we're just gonna keep drilling down, so that we gotta find this config volume. Where is it coming from? So if we come down here, config volume, we can see it comes from a config map that is called core DNS. That's something that's going to be configured in Kubernetes. You're going to have a core DNS YAML file that's probably set up somewhere. Sorry, not core DNS, the config map YAML file that's set up. So let's just do get all config map. Let's find all the config maps that we have configured on this cluster. So let's do get cm for config maps. And let's do -a, just so we can see all the namespaces. We have quite a few here, but it did tell us the name, and it was, what's the name? Something DNS. Name of the config map, core DNS. So let's see, where's our core DNS? Core DNS. CM was still for something else. Just config.
It says Cube System for core DNS. That's not right.
Oh, do you see? Oh, there it is. I was reading the namespaces. Okay. There's our core DNS. Thanks, good catch on it, Leslie. Thank you. So now let's go ahead and describe namespace cube system and config map core DNS. So here's what we got going on in here. Core pass to core DNS. Oh, so we can go ahead and answer this one. It is passed through a config map. So yeah, here's our answer. Configured as a config map object. And what is the name of the config map object created for the core file? That was the core DNS. And what is the root domain zone configured for Kubernetes cluster? Root domain zone. So can we get that from this file? Root domain zone. Looking for the domain. I don't think that's gonna be space. Okay, so our root domain zone is gonna be is the second entry over here. So after Kubernetes, so cluster.local is gonna be our root domain zone. Uh, it's hard to know that just from reading this, I know, but that is gonna be our domain. If we have a pod, yeah, do we have a pod available? Okay, yeah, pods. There's another, as you can see here, like it will go through their Etsy resolve config. So we can actually use that. So let's go on one of the, so this should all be using the same DNS. So let's use the HR app there. So we can do an kexec as we did earlier. And run, we need to select kexec HR. And I want to run a command on that pod. So the command I want to do is I want to do a cat, and I'm gonna do cat Etsy resolve conf. All right. So, and as you can see here, So I guess I should also explain what the root domain is. When you're searching something up, as far as through DNS, there's a certain syntax of how everything's gonna be named, and the syntax is gonna be the name of the object you're trying to reach, the name dot namespace dot type. So it's gonna be either like in this case, you see it says an SVC. That's gonna be our type, and then the last one is gonna be our root domain. So that's what we're looking for. So as you can see here, all of them end with cluster.local. That's gonna be your root domain for this cluster. So let's go ahead and select cluster.local. Does that make sense?
So the root domain is how it identifies that particular cluster in the network.
Is how it's how Kubernetes is able to search for an object in that cluster.
Okay.
So if there was another cluster, it would have a different root domain, and therefore, like you would check for it by different. You would have a different ending to the lookup here.
Okay. Thanks.
No problem. Okay. So next up, we have deployed a set of pods and services in the default and payroll namespaces. Inspect them and go to the next question. So let's inspect the pod. Let's just do a key get pods dash n default. I'm just curious if I can just do two n's, or if it only lets you do one payroll. So it only did the last one. Okay. I was hoping it would show me both these spaces, so let me try this. I'll play with it later. Yeah. Yep. All right. So the apps that we have here is going to be HR, Simple Web App, Simple Web App 122, Test, and in the payroll we got Web. So those are going to be our applications. And they also did create some services as well. So let's do same thing, but we're gonna switch get SVC, and we're gonna switch, take off the N. This should show us the default namespace. So that's gonna be all of our configuration. Okay, so what name can be used to access the HR web server from the test application? HR web server. You can execute a curl command on the test pod. Typically, the test application also has a UI. Access using the tab at the top of your terminal, name test tab. So they have it right here, but we can just use the curl command. And so we want to be able, everything's going to be happening from the test application. So it's going to be, we can exec into the test. Let's get rid of this. Want to be on the test app, and we're gonna run our commands from here. So curl, and they want us to find what name can be used to access the HR web server. Curl HR. So first thing I want to try, what happens when we do just curl HR? Cannot be resolved. So web server from the test application. So we need to find out the service that is connected to that web server, that the HR web server. So let's first do okay, describe pod HR, and let's make this easier on ourselves. I'm gonna grab for the line that has label in it, and the label is gonna be name HR. So, and let me just do just make sure there's no other labels. I'm gonna do a dash A5. Yeah, so that's the only label that we have. And so we're gonna do the same thing now, but we're gonna describe the services. So we don't know which service it is. Describe SVC. This should give us all of the services. And then issue, well, it's only gonna give us all the services in the default namespace, and then we can go from there. The HR app is in the default namespace, so actually this will give us what we need. So we're looking for the label. None. Let me see if it's got it. Okay, let me do I messed something up. Can you describe SVC? Labels. Well, it says this a lot there when it comes to the services. We see it right there. But let's just double check the other ones. Selected none. Okay. So name HR, it matches our label on the pod. So our service is going to be web service. So that's what we need to curl. Because as you remember, we need to hit the service to reach the other pods. So let's go ahead and do our exec again. And we'll try just with the web dash service. Okay, so as you can see, now we're getting, this is the HR server. We are able to hit that server. So, what name can we use? So out of all of these, we can run through all of them, but we know this one is not going to work because as I mentioned earlier, after the dot is going to be, we're going to have the namespace, and this app is in the default namespace. Therefore, if we check the payroll service, we're gonna hit something else. And web is not gonna be it. A test service is not gonna be it because we don't have those services. As any services, maybe we can check all that. Can you give? We see dash A, all the different namespaces. We don't have any services named that. Web test service. There's a test service. So let's check that. Let's go ahead and do that. Girl test dash service. And get a whole bunch of something. This is gonna be, oh, so this is the code for this test application that they got going on up here. Test application connectivity. If we do, I'm curious now. Yeah, here it is. So you can see test application. Then we can see connectivity somewhere down here. That's cool. Please upgrade your browser to improve your experience. Let's see this. That's cool. So you can probably, if you take this code and run it, then you can reuse their test application. Here's the connectivity test. That's cool. Yeah, so web service is gonna be our answer. I'm rambling on here a bit, so if anybody has any questions, of course, just interrupt me at any point. Which of these names cannot be used to access HR service from the test pod? So we don't have the one that includes, I think we did. Let's go ahead. We're on the test. So what the way this works is it's gonna use that entry in what was it? Etsy. Etsy resolve.conf. So that's what it uses to look these up. Get Etsy resolve.conf. So and it goes through each one. So the first thing it tries is the default namespace as it adds these to the end of whatever you search. So in our case, when we search web service, it'll first try the web service dot default dot svc dot cluster dot local. And if you had the web service dot default, it would fail. So the web service dot default would fail. So it will go to the next one. So that's how it works. Does that make sense?
Yep.
So eventually, so all of these, as long as they match the web service that, because it's gonna be the name of your service, the namespace that it's in, the type, which is in this case is a service, and then it's gonna be your domain, which is gonna be our cluster.local. So as long as it matches that, it will work. So web service that default, if you go through these, web service that default, and you hit the second one, that SVC, that cluster, that local, that would work. Web service that default, that SVC, that cluster, that local will work. And which one have we not checked? And web service that default, that SVC, that cluster, that local would also work. This one would not work because the type is not a pod. It is a service. So this is going to be the one that does not work. And which of the below name can be used to access payroll service from the test application? So now we're trying to access the payroll service. And payroll service key. We did that earlier. Get all the services. And here's our payroll service. And sorry. This is the payroll namespace. The service is gonna be pod, I'm assuming -a. Hey, there it is. There you are. So let me walk you through how you would figure this out. First, we just jump onto the pod itself, and as you can see, the pod is called web. It's also it doesn't actually specify anywhere that which app we're supposed to be using. Technically, I'm kind of just giving away the answer, but okay. But if we were just to see this pod and try to figure out how do we reach this pod called web, so the way we would do that is first things first. Let's describe the pod itself. Describe pod, and it's in the payrolls namespace. and web. So we're gonna need its label. As you can see, the label is name equals web. So now we're gonna find the service that uses it. So as we did earlier, k get svc dash a. And this time we're gonna grep for the right thing. We're gonna grep for the selector. Select. And we're looking for one that is name equals web. Really? Oh, that's why. We're not get, we're gonna want to describe. There we go. So name equals web is gonna be the last one. So let's go ahead and do name equals web. And I want to add slash b. Let's just do 100 lines. We don't need all 100, but thought there was only one that's gonna pop up. But here it is. As you can see, the name of that is gonna be web service, and namespace is payroll. I mean, just from that alone, we can deduce what the naming scheme is gonna be, because it's gonna be web service, then the namespace, which is gonna be payroll. Then there's the type, which is gonna be service, and then cluster.local. So what is the question? The question is, which below name can be used to access the payroll service from the test application? So in that case, we need web is the name of, no, the name is web service, web. So we need a web service that payroll. And that's the only one that matches that. So we can eliminate all the other ones. If you use web service, it's gonna check the default namespace first, because the test application is part of the default namespace. So it checks its own namespace first. So you couldn't use that. So you have to specify the namespace. So this is the only option that works. So let's go ahead and go with that. And which of the below name cannot be used to access the payroll service from the test application? So we could just go down the list. Web service, they all start with web service. They all select the payroll, the correct namespace. SVC does not need to be mentioned, so this will still work. And all of these are selecting the right SVC if they were to mention it. So it comes down to between these two. The only difference is cluster, the local versus cluster. The domain, as we saw earlier, is going to be cluster.local. If you just put cluster, it will not work. So that's going to be the one that it does not work. All right. We just deployed a web server called web app that accesses a database. I did not realize this was this long, or would I just did the services instead. But it doesn't matter. We're into it now. We just deployed a web server called web app that accesses a database MySQL server. However, the web server is failing to connect to a database server. Troubleshoot and fix the issue. They could be in different namespaces. First, locate the application. The web server interface can be seen by clicking the web server at the top of your terminal. So let's go ahead and connect to this web server. Okay. So your web server is failing, and here we show all the different variables that are passed through. DB host MySQL, DB database is not set, user is root, password is password. 2003 cannot connect to MySQL server, MySQL. 3306. Name does not resolve. It tells us the error here actually. So the issue is this MySQL is not resolving, and it is set by this variable here. And as we saw earlier, the variables can be passed in through different ways. We can have a config map, or we can just have pass through an environment variable straight to the container. So let's go ahead and find this application that they're talking about, and let's figure out how it's set up first. The web server is called web app, is what they tell us. So let's find the hey, yeah, pause, dash, hey. Okay, so web app. I don't, do we see? Here's MySQL, and here's the web app. And yeah, and it looks like it started 2 minutes ago, so that looks right. I see a bunch of numbers. This shows me that it might be a deployment. So let's do a k get deployments. And there it is, web app deployment. So let's do a describe on a deployment. K describe deployment. Let's see what we got going on here. Well, so here we can see the environment variables are set for this deployment, and MySQL is not resolving. So why is it not resolving? So
Because it's not mountain.
say again?
It's no mount for it. Could that be it?
Well, it's not supposed to be mounted. It's MySQL is a separate, it's gonna be a separate server, as you can see,
Oh,
which
okay. Right.
in this in their wording it's a separate pod. We gotta figure out why web app cannot resolve actually the
Mm.
MySQL. So it could be multiple reasons, but I'm pretty sure it's the namespace issue. But let's walk through how we would figure that out. Just so we know for sure. Let's do a K. Did you say something?
No. Mm.
Okay, sorry. Let's do a K exec on the web app. And girl. This is just gonna confirm MySQL. Actually, what I want to do is cat first slash etc resolve that conf, and that way we can find out exactly what we're looking through. Okay. The next step I want to do real quick, do curl MySQL. Yeah, so can't find it. What's that? Okay. Oh, web. Okay. So oh yeah, so the issue is the command itself. So the command is failing. So next up, let's get more information on this MySQL server. So I saw it earlier, k get pods dash a MySQL. And yeah, right away you can see here the MySQL pod is in the payroll namespace, while the web app is in the default namespace. So as you saw here per the resolve conf, it searches the default namespace first. It's gonna be the only namespace that is gonna check unless we specify it. So if we go back and we do the same command, MySQL, and we specify that we want to check the payroll namespace. Let's see if this works. Does not. So curl is the issue. Can I do a wget? Okay, so you can't connect to it. Okay. So let's go ahead and get out the command. So what we'll do now is we just need to modify that deployment so that it knows how to look up that MySQL server correctly. So let's do k-edit deployment web app. And in the environmental variable, MySQL, we just want to add that payroll here. Escape. Okay, so that's done for now. Let's go back to here and we can do a refresh. And success. It's able to reach it. Perfect. And let's see what it's asking us here. The web server web app uses the right DB host name. I guess it did give us that. Okay, so it should be good. Perfect. Any questions on that one? I know it was a long one.
Oh, that will make sense now.
Perfect. And last one from the HR pod, do an NS lookup, the MySQL service, and redirect the output to a file called root CKS. And they want us to do this from the HR pod. So I'm assuming they want us to redirect that to this file on the HR app. So it's gonna be exec command, and we want to do it on the HR pod, and they want us to do a nest lookup. A nest lookup just looks up the name server for that MySQL lookup SQL service. And as you remember, MySQL. I'm not sure if they're in the same namespace, but just well, let's find out. Let's do a kexec HR and let's look at let's see if this fails. Yep, so this failed. So well, I actually mistyped it. Okay. So where can I find MySQL? Okay, so and the reason for that is they get pods. HR is in the default namespace and MySQL is not. So we need to add that payroll. And there we go. There's its address. And here's its full name, MySQL payroll SVC cluster.local. And its address is 10.107.61.47. We can match this to describe dash n. Wow, let's get payroll SVC. MySQL. And does those two match? 61.47. Yes, they do. So let's not forget about the question. The question was not just to execute the command, it was also to redirect that output. Oh, so it's actually going to redirect it to a folder on this computer. just because the way we have this set up. CKA and S lookup. Okay, so we should be able to cat that directory. All right, perfect. We can see it all there. Does it say what computer to have it redirect to? So I don't know if it wants it on the control plane or if it wants it on the HR pod, but let's check, give it a check. Looks like it's fine with it being on the control plane. So yeah, that is have you worked with Leslie, have you worked with the redirects?
Yeah, I have actually. Redirects and pipes and T were part of what I was practicing with in Linux. So it was kind of cool to see it in action here.
Oh, I'm glad I could show it to you. Yeah, what this does is because if you know that if I mentioned it earlier, the kexec redirects the output that would usually happen on the HR pod, it redirects it to your terminal, and then therefore you're able to redirect it to that directory on this on the control plane versus having it go into the directory on the HR pod.
Mm-hmm.
But yeah, that's the last question. And just to summarize it, in this one we went over the DNS and how it is configured on in Kubernetes. And the main takeaway is the syntax of the names in Kubernetes, which is gonna be your service name, namespace, type, and domain. And every pod, and this is really a Linux thing, is even this control plane is gonna have a resolve.conf, which is gonna be your how it's gonna look up your name resolution. So if we do a cat slash etc resolve conf, yeah, so this one just points to the name server. Let's say to the 25.01. Is that one of our pods? Let me see. I think that is, let's see Kubernetes, if that's the Kubernetes pod. Okay, get svc -a. And the one I want to check is that one that's called Kubernetes. No, cool. kubedns. Let me check that service. Describe. Actually, it says the IP address is right there. So system core DNS. I don't want a pod. I want the service. System. Yes. E10.96.0.10. kubedns. Also, it does mesh. So this is gonna be the name server for this computer. It's the underlying infrastructure DNS server. It's not the Kubernetes DNS. So that doesn't really help us in this case. But what we need is the one that is configured by Kubernetes, which is gonna be this guy right here. And yeah, as you can see here, that one actually does point to our kubedns. But yeah, any questions on on the DNS and Kubernetes.
No, I think we got it.
Okay. That is all that we're gonna cover today. Are there any questions on any of the things that we covered today? All right. I'll go ahead and I'll conclude today's sessions. As always, if you are watching this on the replay, if you found this information valuable, go ahead and like and subscribe. And if you are looking to join our study sessions, just shoot me a message, any of the platforms. And thank you for watching, and I'll see you guys on the next one.